Okay, these are the list of properties of dot product. Okay, so the first one is when you perform dot product for vector u dot vector v, that is equivalent to you perform for v dot u. So you can swap the position between the vector. Alright, so number two, if you need to do dot product to the summation of vector v and vector w, okay, instead of solving the operation in the bracket first and then multiply with dot u, vector u, you also can expand them by doing or performing dot product for uv plus with the dot product of u and w. Okay, same goes to number 3 here. When you need to perform dot product for the summation of two vectors like this, you can expand this as usual. Okay, so you multiply u with w plus with u p plus with vw plus with vp. So you will have 4 terms to add. Okay, and then let's say if you have a scalar k here, you need to multiply with dot product of vector v and vector u here. You also can multiply the scalar to one of the vector and then perform the dot product. Okay, so I have explained about the fifth property here, where when you perform dot product, j dot j will equal to 1, and this is also equivalent to I dot I equivalent to k dot k. Okay, so you get 1. Alright, and this one is related to the formula of cos theta equal to u dot v over the magnitude of u times the magnitude of v. Okay, so when dot product of u and v here is equal to 0, okay, you will get theta equal to 90 degree. 90 degree means your vector u and vector v are perpendicular. So that's why, okay, when you find out the dot product between the two vectors equal to 0, okay, automatically you should know, okay, that these two vector u and vector v are perpendicular or orthogonal. Okay, perpendicular. Okay, even though without applying this formula. Okay, once you determine that u dot v is equal to 0, you don't need to apply this formula, the cosine formula, to find the theta, because the properties say these two vectors are perpendicular or orthogonal whenever the dot product is equal to 0. Okay, so you don't need to proceed calculate or substituting the value in the formula. Alright, say dot product of the different component will give you 0. Okay, so if you dot product different component, for example I dot j or j dot k or k dot I, this will give you 0. Okay, but if you dot product same component, this will give you 1. Okay, I dot I, j dot j, k dot k are all equal to 1. But for different component, dot product of different component, it is 0. Okay, and when you perform dot product of the same vector, that is equivalent to the magnitude of that vector square. Okay, let us proceed to look at the example for the dot product between the two vectors. Okay, so here you have vector u and vector v. Okay, So here you need to apply the formula of cos theta u dot v over vector magnitude of u times the magnitude of v, because here you are dealing with two vectors. Okay, so it is not about the direction angle or cosine angle. Okay, direction cosine, because direction cosine and direction angle is between one vector and an axis. Okay, so this is not about the direction angle or direction cosine, but this is about the dot product between two vectors. Okay, so this is how you determine which formula to use. Look at whether you have an angle with an axis, or you have two vectors. Okay, when you have two vectors, you use this formula. Alright, so here you need the dot product between u and v. You also need the magnitude for vector u and magnitude for vector v. Okay, so now let us do one by one. Find the dot product for u dot v. Okay, so 1 minus 2, 3, dot with 2, 3, 4. So you will get 1 times 2, that is 2, plus with minus 2 times 3, that is minus 6, plus with 3 times 4, that is 12. Okay, so solve for this summation. You will get 2 minus 6, that is minus 4, plus 12, that will give you just 8. Okay, and then find the magnitude for vector u, that is equivalent to 1 squared plus minus 2 squared plus 3 squared, that is 1 plus 4 plus 9, that is square root of 14. Okay, then find the magnitude of v, that is equivalent to 2 squared plus 3 squared plus 4 squared. So that is 4 plus 9 plus 60, that is square root of 29. Alright, now apply everything into the formula of cos theta. U dot v is 8. Okay, magnitude of u is square root of 14. Magnitude of v is square root of 29. So this will give you 8 over the square root of 406. So this is equivalent to 8 over 20.15. Okay, and when you solve for this, you will get 0.397. So cos theta equal to 0.397. Theta is the arc cos of 0.397. Okay, insert this into your calculator. You will get 66.61 degree. Okay, so the angle between vector u and vector v here is 66.61 degree. Okay, so now let us do for number 2. Okay, number 2, u dot v equal to 2 0 minus 3 dot with 4 0 minus 6 is equal to 2 times 4, that is 8, plus with 0 times 0 is 0, plus minus 3 times minus 6, that is 18. Okay, so it is 26. Okay, so the magnitude of vector v is the square root of 2 squared plus 0 squared plus minus 3 squared, that is 4 plus 9, that is square root of 13. Okay, so v is 4 squared plus 0 squared plus minus 6 squared, that is 16 plus 36. Okay, this is 4, 5, 2. Okay, 52. Square root of 52. Then applying into cos theta equal to u dot v, okay, is 26 over square root of 13 times square root of 52. That will give you 26 over square root of 676, which is equivalent to 26. Okay, so 26 over 26 is equal to 1. So cos theta equal to 1 will give you theta equal to 0 degree. So what does it mean when your theta equal to 0 degree? It means that u and vector v are parallel. Okay, so they might be parallel in this way, or they might be in line. Okay, because they are parallel. Alright. Next, I will show you the second method of performing multiplication between two vectors. Alright, so that is cross product. Okay, that is cross product. Alright, in order to perform the cross product, let us assume as usual that you have vector u in this component and vector v in this component. Okay, where we know each of these component is I, J, K. Same goes to this is I, this is component J, this is component K. Alright, so U is our first vector and V is our second vector. So when we perform U cross V, okay, this is how you write the multiplication. Alright, so the first vector, which is vector u, you write it in the first row. Okay, and the second vector, which is vector v, you write it in the second row. Alright, and if you look at by column, the first column is the component for vector I. Okay, you check. The component for vector I is u1 and v1. So you have u1, v1. That is your I component for both vectors. Okay, and the second column here is for j component. Okay, check the j component for the two vector. You have u2 and v2. So u2, v2. Okay, and the third component is k component. Okay, so k component is u3 and v3. So you have u3, v3. Okay, understand? Alright. Okay, now let us look at how to perform the cross product. Okay, so first thing that you should know is the I component is always positive. The J component, you will perform subtraction. For the K component, it back to positive. Okay, so positive, negative, positive. Alright, now we will calculate the component I. Okay, so in order to find the component I, what we do is we assume that this component is gone. Okay, it is not gone, but we just assume that we don't consider the value for component I. Okay, we don't calculate or we don't involve the component I to find the value of I. Okay, so component I will only involve the calculation or the numbers in J and K. So what you do is you multiply U2 with V3, multiply this, you minus with the multiplication of U3 times V2. Okay, so it is always subtract for the operation in the bracket. Okay, so when you're done with I, you will calculate for J's component. So you will repeat the same thing. Since you want to find the J component, you will delete, okay, temporarily the value of J column. So this we're gonna delete it. Okay, so we delete this column temporarily. Okay, since we are calculating for J component, so we just ignore the value U2 and V3 here. Okay, and then we perform the same thing. We multiply U1 with V3. So multiply this minus, okay, minus with the multiplication of U3 times V1. So minus U3 times V1. That is for component J. Alright, so this negative you get from this. For J, it is always negative. So you will get alternate sign, which is positive, negative, back to positive for K. Okay, so for K, we will repeat same way. Okay, so temporarily delete this. Alright, and just consider the multiplication of U1 times V2 minus with multiplication of U2 V1. Okay, so you get component K. Right? Or you can write this in vector form A, B, C. Okay, where your A is this is your B, and this is your C. Alright. The interesting part of performing the cross product between two vectors is the creation of new vector that is called normal vector. Alright, so when you perform cross product between U and V, it will create a new vector at the joint or at the vertex, the point. that join the two vector, it will create a new vector pointing upward. Okay, and this vector is called normal vector. Okay, and these vectors create 90-degree from both vector. It is 90-degree to vector u and a 90-degree to vector v. Okay, so that is normal vector. Okay, so if your vector u is here and vector v is here, when you perform the cross product between your u and v, it will create a new vector pointing upward, where this is the resulting vector called normal vector. Okay. Alright, so we create here at the joint of the two vector, it will create a new vector called normal vector. And the property of normal vector is the angle between your n and your v is 90-degree. Same goes to the angle between n with u, also 90-degree. Alright, but for u, vector u and vector v, the angle is not necessarily be 90-degree. It depends. Okay. And thus, when n to vector v is 90-degree and n to vector u is 90-degree, okay, vector uv is said to be orthogonal to both u and v. Right? So any vector that create 90-degree angle is always said to be perpendicular or orthogonal. Alright, so the normal vector is perpendicular to both vector u and vector v. Okay, so these are lists of the properties of cross product. Okay, cross product of vector u cross vector v is equivalent to v cross u. Okay, same goes to the addition between two vector, and then you can cross product with u, right? That is equivalent to expanding the bracket. Okay, still need to remain the operation cross product. Okay, same goes to multiplication of a scalar to vector u cross vector v. You can multiply k to any of the vector first, okay, whether k multiply u and then perform the cross product with v, or you can multiply k to vector v and then perform the multiplication with vector u. Okay, any vector, whether it is u or v, if you cross product to 0, you get 0. Okay, when you perform the cross product and you get the result equal to 0, automatically you know that u and v are parallel. Okay, because you got theta equal to 0-degree. Okay, so when your cross product is equal to 0, okay, you will get theta equal to 0-degree. When theta equal to 0-degree, u and v are parallel. Okay. when u and v, okay, when you got theta for u and v equal to 90 degree, they are orthogonal or they are perpendicular. Okay, so you must remember these two important property. Okay, for cross product, we are no longer using the cos term. Okay, so we will use the sine term, which is sine of theta, okay, is equivalent to the magnitude of u cross v over the magnitude of u times the magnitude of v. Okay, so you need to apply you need to calculate for magnitude u cross v. Because u cross v, you will get a vector. Okay, in order to find the theta, you need to find the magnitude for this. So a squared plus b squared plus c squared, find the square root. Okay, and then you substitute in here. Okay, this is the magnitude for u and magnitude for v. That will give you a number. Okay, that is your theta. Alright, so when you do cross product for the equal component, for the same component, okay, I cross with I, J cross with J, K cross with K, you will get 0. Okay, that's why we cannot perform the cross product for u and v the same way that we apply for dot product. Because for dot product, you will get I dot I, J dot J, K dot K, which is equal to 1. But for cross product, if you multiply, you get I cross I, J cross J, okay, cross K. These are equal to 0. Okay, so it won't work to multiply the cross product as normal way. Okay, right. When we perform the cross product for u and v, this is how we write it, right? I, J, K, and this is the component for A, B, C, D, E, F. Okay, so remember I said to find for component I, we assume that we delete this column, because when okay, because the multiplication of this is J. Okay, and then you cross product C and E here, means you cross with K. So J cross K will give you I. Okay, so J cross K, you got I. Same goes to when you apply for J, when you want to calculate for J. That's why we assume that we delete this column, so we will multiply, or we will do cross product for I cross K. This will give you J component. Okay, so J component. Okay, and this one as well. Alright, if you swap the way you multiply, you cross product the I and the J, you will get negative value. Okay, so if I normally you cross I with J, you got K. If you swap the position, you cross product J with I, you will get negative K, and so on. Okay, so if you swap the position, okay, of ik to ki to ik, you get negative. Right, so before we end the lecture, let us do an example on performing the cross product between vector u and vector v. So u cross v is equal to, write it like this. Okay, so you have I, j, k. So the first vector is vector u, so you write the whole thing here according to the component 1, minus 2, and 3. So this is our second vector v, so write it at the bottom, the second row. Okay, so 2, the j is 3, the k is 4. Alright, so look at carefully. Now we will perform the cross product. So to find for I, we pretend that we delete this column. Okay, so we will cross product with this. So minus 2 cross with 4, that is minus 8. Right? So you will minus with the product of 3 times 3. So minus with 9. Okay, so according to the property, when j cross product with k, you get I. Okay, then we do for the second component with which is j. So remember j is negative, so put negative here, right? And then open the bracket. We do for j. Okay, so we will delete, pretend that we delete the j. Alright, so we do the cross product 1 multiply with 4, that is 4, and minus, because the operation in the bracket always minus, minus with 3 times 2, which is 6. And the multiplication between I and k here, okay, cross between I and k, you get g. Okay, so then proceed k, k is positive, so back to positive, and then open the bracket. So we repeat the same thing, pretending that we delete this column so that we won't confuse. Okay, we just see 2 columns to multiply. Alright, so multiply 1 with 3. So you get 3, always minus. The multiplication of minus 2 times 2, it is minus 4. Another bracket, and the multiplication or the cross product between I and j, you get k term. Okay, and then solve the operation. Minus 8 minus 9, that is minus 17 I. Okay, minus with 4 minus 6, that is minus 2 j, plus with 3 minus with minus 4, that is 7 k. So the answer is minus 7i plus 2j plus 7k, or minus 17 to 7. Okay. Right, if you were asked to find the angle, what you need to do is you apply the sine theta. Okay, sine theta of u cross v over the magnitude. This is also the magnitude of cross product u and v times u magnitude u dot magnitude v. Okay, so we have performed for u cross v. We got this. Okay, so then find the magnitude of this. Magnitude of u cross v here is equivalent to the square root of minus 17 squared plus 2 squared plus 7 squared. That will give you square root of 342. Okay. Then find the magnitude for vector u. Okay, so that is square root of 1 plus 4 plus 9 is square root of 14. Magnitude of v, that is 2 times 2 is 4 plus 3, that is 9 and 16, that is square root of 29. Okay, so apply all this value in this sign formula. Square root of 342 over with the square root of 14 times square root of 29. That is equivalent to 7, 8. So theta is arcsine of 0.9178. You get theta equivalent to 66.61 degree. Okay. So next, let's do for the second example. So U cross V, I, J, K. So the first vector 2, 0, minus 3, 4, 0, minus 6. Okay. So this is equivalent to doing for I. Okay. So this is cross product of this 0 times with minus 6. Put a bracket, don't forget. Minus with the cross product of this. Okay. Minus 3 times 0. Close the bracket. You got the component for I. Okay. Doing for J means you cross product 2 with minus 6. Okay, don't forget because J it is minus. Open the bracket. 2 times minus 6 minus with minus 3 times 4. Close the bracket. That is component for J. And now doing for K. Back to positive. So okay, doing for K here, it is 2 times 0 minus with 0 times 4. Close the bracket, and this is for K. Alright, so solving this, you got 0 minus with 0 for I, minus with, this is negative 12, plus with 12, that is your J, plus with 0 minus 0, that is for K. Right? So this is equivalent to 0. So you see here, cross product of U, V is equal to 0. Okay, when you apply into this, you will get 0 for that, and sine theta will be equal to 0, and automatically you get sine theta is equal to 90 degree. Sorry, not 90 degree, it is 0 degree. Okay, 0 degree. Sorry, so get 0 degree because sine of 0 degree equal to 0. Alright. So what does it mean when your theta is equal to 0 degree? It means that your vector u and vector v are parallel. Okay, so u and v are parallel. Okay, or they might be in line, in the same line. U, v. Okay, so without replacing 0 into sign formula, okay, when you got cross product of vector u and vector v is equal to 0, automatically by applying the properties, you should know that these two vector u and vector v are parallel. Okay, so the theta or the angle between these two is 0. Okay, so hopefully I am explaining all this clearly, but if you still cannot catch up, okay, if you still do not understand, please don't hesitate to ask. Okay, so it will be easy to consult one-to-one, okay, rather than I just generally explain in the slide. Okay, so I guess that's all for this second lecture. I meet you in the next meeting. Thank you very much and Assalamualaikum.